Today you will be solving quadratic and polynomial inequalities. So let's review a little bit of how we did or graphed inequalities on a number line like we did in Algebra 1, more than likely. So if you had something like x is greater than 4, right, you would have your number line and you would put a couple values on the number line. And remember, for a greater than sign, we use an open dot or a parenthesis. And because greater than means larger, we want to face the parentheses to the direction of our solution. So our solution would be something like this. And then if you recall, we wrote our solution as 4 to infinity. Now, a parenthesis for the 4, and always with infinity signs, you will use a parenthesis. Okay, so let's look at x is less than or equal to 2. So we put a couple values on a number line, and for a less than or equal to sign, we either use a solid dot or a straight bracket. And because we want less than, we want the bracket to face the values that are smaller, and then our solution set is to the left. And we write our solution always from smallest to biggest. So we'll start with a negative infinity all the way to a 2 with the straight bracket. On the flip side, if we had something already in set notation, we can say we have negative 2, and then eventually we'll have 3. Now, negative 2, because the parenthesis is facing to the right towards negative 2, we want to have the parenthesis facing the same way. And then for 3, the straight bracket. And then our solution set is everything in between. Now, if we look at the negative infinity to negative 1 union 2 to infinity, we know we're going to have a negative 1 and eventually a 2. Now, negative infinity to negative 1, there's a parenthesis, so we'll use a parenthesis facing backwards, and that solution set is this way because negative infinity means all values less than negative 1. And then we have 2 to infinity, and notice there's a straight bracket on the 2 and it faces to the right. So I also want to draw my straight bracket facing to the right, and everything larger than that is to the right of 2. So let's talk about the definition of a polynomial inequality. Any inequality in the form f of x is greater than 0, less than 0, less than or equal to 0, or greater than or equal to 0, where f of x is a polynomial function. Okay, and we like the graphs because they can help us visualize solutions of polynomial inequalities. So notice we have an example, x squared minus 7x plus 10. So our solutions, meaning when we factor and set the factored binomials equal to 0, we get the critical values or the solutions or the x-intercepts. So notice we have our x-intercepts at 2 and 5 when we factor and solve. And those are our boundary points because that's when we're shifting away from, are we less than 0, greater than 0, less than or equal to, etc. So we will use these x-intercepts to help us find the solution set for our polynomial inequalities. So notice everything below the x-axis is less than y equals 0, okay? Everything above the x-axis is greater than 0, okay? So it's just a nice visual, and we're ready to, walk through the process. So in our first example, we're going to solve x times x plus 3 times x minus 2 is less than 0. So we have a sequence of steps that we will follow. The first one being, does our inequality equal 0? Hopefully you say, yes, it is equal 0. Next thing we're going to do is we're going to factor the inequality. Okay, notice our inequality is already in factored form, so we're ready to move on to the next. We're going to find the x-intercepts, also known as the boundary points. Okay, let me zoom in just a smidge. Okay, so when we set each of our factored pieces equal to 0, notice we'll have x equals 0, x plus 3 equals 0, and x minus 2 equals 0. So what that means, we'll have x equals 0, x equals -3, and x equals 2. And then if you look, notice we're going to locate the points on the number line. So because those are technically zeros, I'm going to mark those as like open circles to represent zeros on our number line here. And then that's all she wrote. Okay, so the next step is to test one value between each interval. Okay, and this is where it varies. You can choose a wide range. So notice we can, I don't know what's left of -3. Let's test x equals, I don't know, -5. So what that means we'll do is we'll place -5 into our factored form and see what kind of sign that gives us. Okay, so it looks like we'll have a negative number. -5 plus 3 is also a negative number, and -5 minus 2 is also a negative number. And a negative times a negative is a positive, times a negative is a negative. And so I'm going to mark that as negative. Okay, so let's test something between -3 and 0. Let's say we wanted to test x equals, I don't know, -1. And you can pick anything between those two values. So if we test -1, it looks like we'll have -1 times -1 plus 3 times -1 minus 2. And notice we'll have a negative. -1 plus 3 is a positive, and -1 minus 2 is a negative. And we know negative times a positive is negative times a negative is a positive. Okay, so now we have to test something between 0 and 2. So let's test x equals 1. Okay, so we plug in 1 for all the x's. 1 times 1 plus 3 times 1 minus 2. So we'll put plus a positive number times a positive number. 1 minus 2 is a negative number. And we know a positive times a negative is actually a negative. So we'll put a minus sign. And then last but not least, we're going to test something larger than 2. Let's say we have, I don't know, x equals 3. So we'll have 3 times 3 plus 3 times 3 minus 2, which gives us a positive times a positive times a positive, which is a positive. Okay, so all that's left for us to do now is to write our solution set that satisfies the original inequality. Okay, so that's what we're going to do next. So because we have a less than means we want the negatives. Okay, and because it's a less than sign, we're going to use the parentheses. So I'm going to put parentheses facing our negatives. So it's almost like we sandwich those negatives. And now all that's left for us to do is to write our solution set. So we always write it from least to largest. So if we have our backwards facing parenthesis at -3 facing all negative numbers, we'll say -infinity to -3. We'll put a union. Well, not a straight bracket, it's a less than, so a parenthesis 0 to 2. And that's your solution, the end. Okay, so we're going to look at another example, and notice we have the same steps as we had previously. So the first thing we're going to ask ourselves is, does the inequality equal 0? And in this case, it doesn't. So we have to make it equal 0. In order to do so, we're going to subtract the 15 on both sides. So 2x squared plus x minus 15 is greater than or equal to 0. Our next step, notice it says we're going to factor the inequality. And you can factor with grouping or you can factor with guess and check. It really doesn't make a difference. So I'm going to go off to the side, and we know we're going to take 2 times -15. So 2 times -15 we know is -30. And the factors of 30 are 2 and 15, obviously, 1 and 30, 3 and 10, and 5 and 6. So we're going to ask ourselves which pair of factors adds to give us the middle positive 1x. And hopefully we recognize we're going to use a negative 5 and a positive 6. So when we set up our parentheses here, we know what times what equals 2x squared when we have a 2x and an x. So now we're going to ask ourselves, between these two values, negative 5 and positive 6, which is divisible by 2? And we recognize the 6's. So I'm thinking in my brain, because when I redistribute, I want this to equal a positive 6x. And so 2x times what number equals 6x, and it's positive 3. And so that means the other one is negative 5. Okay, so that was that step. Next step, we're going to, we haven't done the solution, hold on. So now we're going to set each factored piece equal to 0. Notice we'll have x equals 5/2, which is the same thing as 2.5, and x equals negative 3. Now we're ready for step 3. We're going to locate the intercepts, aka the boundary points. Okay, so our intercepts, our boundary points, would be 2.5 positive, put a 0 for 0, and negative 3. Okay, and we're going to locate the points on the number line, which we just did. And now we're going to test one value between each interval, just like we did previously. I'm going to zoom in a little so we can see better. Okay, so you can test anything in between the zeros as long as you do all the regions. So notice, I don't know, let's test negative 5 again. When I plug negative 5 into our factored form, we will have negative 10 minus 5 times negative 5 plus 3. So notice we'll have a negative times a negative, because negative 10 minus 5 is negative 15, and negative 5 plus 3 is negative 2, which would give us a positive. So I'm going to put a plus sign. I probably choose 0 to test because it's easy in between the two zeros. Okay, so we'll have 0 minus 5 times 0 plus 3, or a negative times a positive, which is a negative. So I'll put a minus sign. And then, I don't know, let's test 5. Okay, so let's see. We'll have 10 minus 5 times 5 plus 3. So we'll have a positive times a positive. And then if you notice also that we went from a positive, then to a negative, then to a positive. So the sign switched in between the zeros. That should be the case, at least in this class. Okay, so then our last step is to identify our solution set. So remember, in our original inequality, we have a greater than or equal to. Okay, so I'm thinking in my brain, greater than or equal to means we want the positives. Okay, and because it's greater than or equal to, we're going to use a straight bracket. So notice we have a straight plus sign, everything's smaller than negative 3, so we'll use a straight bracket. And we have a plus sign, everything larger than 5/2 or 2.5, and we'll use a straight bracket there. All that's left for us to do is to write our solution set in set notation. So we'll start with negative infinity because all the x values are getting smaller, to negative 3 with the straight bracket, a union, and then we'll have straight bracket, that's a straight bracket, 5/2 to infinity. And so that's all we do. I want you to take a nice hot minute and try this example you tried. Okay, so hopefully for this last one, when you subtract the 20 in factor, you do get x minus 5 times x plus 4. And in your final solution is negative 5 to 4 with parentheses.